Welcome to Ask and Learn.
This question, you need to use the capacitance formula A epsilon naught divided by D. So the first part asks you to find the capacitance. So area is given to be 2 meters square. So let's substitute that. Distance is given 3 millimeters. 2 times 8.8 times 10 power negative 12 divided by distance is 3 millimeters. So 3 times 10 power negative 3 meters. Remember, your units should be consistent. So the answer here is 5.9 times 10 power negative 9 farad. Now, the next part is to find the charge on capacitor, which is C times V. We are given the potential difference, which is 45. So you need to multiply capacitance by 45. You will get the answer as 265 times 5 times 10 power negative 9 coulomb. Since you want to keep the answer in just two significant digits, it's 2.7 times 10 power negative 7 coulomb. Next part is to find the energy stored. Energy stored in this case is half CV square. Since we know the C is 5.9 and applied potential is 45, the answer here is just multiplication of capacitance and potential difference squared. So your answer will be given by 597.3.7 times 10 power negative 9. So let's keep the answer in just two significant digits. So your answer again now is 6.0 times 10 power negative 6 joule. This is energy stored. Now, there is a part which also asks you to find the electric field. Now, electric field, let me write it as EF equals V divided by D. So the potential difference is 45, distance is 3 millimeters. So I need to write in terms of meters. This will give me 15,000 volt per meter. See, the units are different. For energy is joule and for electric field it's volt per meter. Now, next part asks you to find the same quantity when the slab of plastic is inserted with the dielectric constant of 3.2. So capacitance now, the final capacitance will be just dielectric constant times the initial capacitance. So dielectric constant is 3.2 times 5.9, which was initial capacitance. So your answer now is 3.2 times 5.9, that is 1.9 times 10 power negative 8. See that I have tried to keep all the answers in terms of two significant digits. In this case, charge stored is also multiplied by K, that is dielectric constant, from the initial charge. So K times Q, let me write it 0 here so you understand it is initial charge or initial capacitance. So what initial charge was 2.7 times 10 power negative 7. So if you perform that operation, it's just 8.6 times 10 power negative 7 coulomb. Now we are supposed to find energy stored. Since energy stored is half CV square, your energy will also be multiplied by factor of kappa. So your energy now will just be 3.2 times this 6.0. This gives you 1.9 times 10 power negative 5 joules. On the other hand, electric field will be unaffected because it doesn't have the factor of capacitance in it. So you will have, it's just V divided by D, so 15,000 volt per meter.